Hello everyone and welcome back to the channel. In this video, we are diving into the new Bayes, one of the most widely used algorithm for classification tasks in machine learning. It's simply fast and surprisingly powerful. But how does it work and what are its strengths and weaknesses? Let's break down into together. Introduction to new Bayes. Firstly, what exactly is new Bayes? Bayes is a supervised learning algorithm that is commonly used for classification tasks. It's called NEO because it makes a rather stronger assumption, namely that all the features in your dataset are independent of each other. And while this might not be true in real life, it still works quite well for many practical problems. Here's how it works. Neil Bayes Bayes calculates the probability of an instance belonging to a particular class based on probabilities of the individual features. The class with the highest probability is then selected as the predictions. Now, Bayes' theorem, the core of Neo Bayes. Let's dive into the Bayes' theorem, the heart of Neo Bayes. Bayes' theorem, P of H equal to P into H into P of H upon with P of E. Bayes' theorem provides a way to calculate the conditional probability of a hypothesis. Given some evidence in the new Bayes algorithm, this allows us to calculate the probability of a data point belonging to a specific class given its feature. Breaking it down, P of He is the probability of hypothesis H. Given the evidence E, P of P of E and H is the likelihood of the seeing the evidence. Assuming the hypothesis is true, P of H is the prior probability of the hypothesis and P is the evidence. Now we will be discussing the assumptions of new bills. Now new bills relies on two key assumptions. Feature independent. First, it assumes that the features are independent to each other. This means that one feature does not influence the other, which in reality is often not the case, but bills still works surprisingly well. Equal importance of features. New bills also assume that all features are not equally important. This can be implemented especially if some features are more important than others. Linearity and normality. Additionally, new bills assumption is a linear relationship between features and the target variable, and it often assumes that the features follow a normal Gaussian distribution. This assumption might not hold every dataset, but new bills can still perform well. Now we'll be discussing the advantages and limitations of new bills. Let us take a look at the pros and cons of new bills. Advantages. On the positive side, new bills is simple to implement and understand. It requires less training data compared to many other algorithms. And it performs really well in multi-class classification problems. Plus, it can handle both continuous and discrete features. However, now the limitations of new bills. However, new bills does not have its limitations. Its independent assumption does not always hold in the real world. And it can be sensitive to the scale of features. Also, it does not handle highly corrected features well. And it has a linear relationship between the features and the target variable. Next in we have implementations of new bills in Python. Let's walk through a quick example of implementing new bills in Python. We will be using a spam classification task where we classify email as their spam or not. First step, data preparation. First, we need to clean and reprocess the data set. This includes handling missing values, encoding character features, and splitting the data into training and test sets. Next, we train the new bills model using the training data. estimating the prior and conditional probabilities. Step 2, model training. Once the model is trained, we evaluate the performance using metrics like accuracy, precision, recall, and F1, which we have covered in our previous video. Our next subtopic for the PPT is example spam classification. Here we use the dataset as the first, use a dataset of email messages labeled as either spam or ham, not spam. Secondly, feature extraction. Extract features from the email text such as word frequency, email length, and presence of certain keywords. In this, we go through the words, frequencies, and email lengths. Next, we have to do model training. Train a model-based classification to predict whether an email is spam or ham based on the extracted features. It is done on the extracted features which we have classified like frequency, email length, and so on. The last step is evaluation. Test the model's performance on a held out test set and calculate metrics like accuracy, precision, and recall, and F1 score. These are the evaluation of the models on the basis of its working. Now we will be discussing the conclusion and the key takeaways from this PPT. So what we have learned about Neo Bayes. Key takeaways. Neo Bayes is easy and simple to implement and works well with many classification tasks. It is independently assumption may not always hold true, but it still provides strong results as its versatile algorithm that handles both continuous and discrete features. It's particularly effective in text classification problems like spam detection. So that's all for today. Introduction to new bills. If you found this video helpful, don't forget to like and subscribe and hit the bell icon for more machine learning tutorials. Got any questions or want to see more examples? Please drop a comment below. Thank you for watching and I will see you in the next video. Keep learning. Thank you.